Determine the current flowing through the galvanometer as shown in the figure. Look at the diagram. Here 2 ampere enters the circuit. It becomes I1, I2 from the point P. I1 reaches Q and splits it into Ig and I1 minus Ig. I2 reaches S and splits into, Ig adds with I2 and becomes I2 plus Ig at S. Then finally I1 minus Ig and I2 plus Ig joins, Ig cancel. We once again get I1 plus I2. That's what we call it as 2 ampere. Good. Path. The case here, Kirchhoff current rule at a junction, sigma I equals 0. KVR, Kirchhoff voltage rule in a loop, sigma IR equals sigma epsilon. These are all the two formulae we are going to use to solve the problem. Solution. Applying KCL at the junction P. Here you have the junction P where we are going to apply the Kirchhoff's rule. Good. Few parts are not labeled. We have to label them one by one. The 2 ampere has to be labeled as I. Good. The 5 ampere has to be labeled as R1. 15 ohms is labeled as R2. Then 10 ohms is labeled as R3. Then 20 ohms is labeled as R4. Then once again the 2A is labeled as I. Good. Now we are going to apply the KCL at junction P. The I that enters the junction equals the sum of I1 plus I2. Let us write I equals the total current flowing into the junction equals the total current going away from the junction. From here we measure what is I2. I2 equals I minus I1. Let us write this here separately for further use. Here we know the value of I, that's 2 ampere. We will be substituting it later in our cases. Now, applying KVR around the loop PQSP. PQSP. Before that, we have to decide the direction of traversal. Here we take it as clockwise direction. Good. Let us form the loop PQSR. In this loop, I1 is in the direction of traversal. So I1 R1 is positive. Good. Plus I1 R1. Then the direction of Ig is in the direction of traversal. So IgG is positive. Ig RG. Good. Then look at I2. This I2 direction is against, opposite to direction of traversal. So I2 R2 is negative. So no EMF in this route. So equals 0. Now we are going to substitute the value of I2. Before that, we are substituting the value of R1, RG, good, and R2. R1 is 5 ohms, so 5 times I1, RG is 10 ohms, 10 times Ig, R2 is 15 ohms, so 15 times I2. Now let me substitute the value of I2 as I minus I1. Good. So here we expand this 5I1, then here minus into minus plus 15I1. So 5I1 plus 15I1, we get 20I1. Before that I is being substituted as 2. So let us go along the way. 20I1 plus 10Ig minus 30 equal to 0. This 30 will be going to the right hand side and it becomes plus 30. Now we divide the equation by 10. So we get 2I1 plus Ig equals 3. This, let us write it as equation number 2 in the left corner. Good. Now let us apply KVR around the loop QRSP. QRS again Q. Good. Now I1 minus Ig is in the direction of traversal. So I1 minus Ig is positive. Plus I1 minus Ig into R3. Good. Next, this I2 plus Ig is in the direction opposite to the direction of traversal. So I2 plus Ig into R4 is negative. Good. then the Ig is in the direction opposite to direction of traversal. So Ig Rg is negative. No EMF in this closed path, so right hand side becomes 0. Good. Now, let us substitute the value of R3, R4 and Rg. Now let us substitute the value of R2, sorry, I2. I2 is I minus I1, right? So now 10 times I1 minus Ig minus 20 times, in the place of I have written 2 minus I1 plus Ig minus 10 times Ig equals 0. Now 10 times I1 minus Ig minus 20, 2 minus I1 plus Ig minus 10 times Ig equals 0. It's repeated. Okay. How many I1s are there? Here you have 10 I1. Good. Minus of minus plus another 20 I1. Totally 30 I1. Good. Now, how many Igs are there? Here you have minus 20 Ig. Here you have minus 10 Ig. And here you have another minus 10 Ig. Totally minus 40 Ig you have. Then, how many constants there? Minus 20 into 2, you have minus 40. Good. The minus 40 go to the right hand side, becomes plus 40. Then divide the whole equation by 10. We get 3I1 minus 4Ig equals 4. Let us take this equation number 4. So here you have 2I1, here you have 3I1. We have to cancel this I1 part in these two equations. So the second equation is multiplied by 3 and the third equation is multiplied by 2, so that the I1 term gets cancelled. We get an equation only in Ig. That will be the answer for the question. So first equation is multiplied by 3. So 6I1 minus 8Ig equals 8. 3 to 6. Sorry. This is the second equation is multiplied. 6I1 minus 8Ig equals 8. Then the first equation is multiplied by minus 3. So you get minus 6I1 minus 3Ig minus 9. So when we add these two, we get 6I1 minus 6I1 getting cancelled. We get minus 11Ig equals minus 1. So Ig equals 1 by 11 is the answer. Ig equals 1 by 11 ampere. Thank you, children.